Please welcome Marcelo Perazolo.
Thank you, guys, and I'm happy to be here. So get started with monitoring converged infrastructure Nagios on IBM Power Systems, right? So a little bit about myself and my team, right? So we are like an old team on IBM that we're doing other stuff, and then we formed a new team to start working on monitoring what we call converged infrastructures. I think some of you might be aware of the terminology, right? And I'm going to explain a little bit more what this is later for those who don't know it. So we want to put together these converged infrastructure monitoring systems using open source software, right? So that was one of the reasons why we started looking at projects like Nagios and other types of software outside IBM. Okay, so going forward, so the agenda. So first I'm going to do a first level set on some of the terminology, like what's, well, for those who don't know, what's IBM Power System, right? What's converged infrastructure, then why we're getting to use Nagios to monitor that. Then I'll talk a little bit more about the architecture of the converged infrastructure solution that we're putting together, the first one. So we'll explain how the Hypervisor works, the virtualization layer on the converged infrastructure works, and how we put together the different applications, including Nagios, to form the management stack on that solution. So after that, deep dive on integration details, how we build our own integration application surrounding Nagios, and what else does it does, right? So how it helps configure Nagios and etc. And then some discussion on what we've been working currently and in the future as well, scaling considerations and the future ideas for expansion. So first off, why Power? So Power is architecture for processors. It's similar to, well, not similar, it is alternative to Intel processors, right? So just going to go quickly about this because most of you may have already heard about it. So the biggest difference with Power was that the way it encodes the data on the processor, it's different. It's called endianness. So Power processors up to Power 7 architecture, it use a big endian to encode data. And now with Power 8, it supports both big endian and little endian, right? So little endian is what usually the Intel world uses. And this is just some information here about, okay, so they try to make it cost competitive with Intel, right? So now that the endian is supported in the new Power 8 systems, it's much easier to port applications to be used in Power System as well. And then that fulfills, like, it makes it much easier for other organizations to consider to use it. And then the next chart is just a little bit more exploration on this. So with this endianness being similar to Intel Word, it's just a matter of 95% of the applications, you just recompile it and they work as is. This is for C, C++, for interpreted languages like Java and Python and others, they work straight off, right? Okay, so what is a converged infrastructure? For those who don't know, I like to call it a data center in a box. So basically, it's a solution that has all the elements that you would find in a real data center, but it's compact, right? So If you look at the right side, it shows what we put together as the first offering. It's called a PurePower system. It was delivered on June. And it has three types of networking on it. The first is a high-speed data network. So it connects your applications, so they have to do, for example, analytics and applications that have a high need for high-speed data. So they use that network in the solution, right? Then there is management network. So that is where Nagios plugs in. So this connects all the components of the system, and it provides the data that you need to monitor it. So it's a lower speed network, but because it's all connected to the rack, right? So it doesn't need to be as powerful as the data network. And then there's a fiber channel switch on the solution as well. That's for networking storage. Besides that, there's a V7000 controller. So this is something that you can use to add storage easily to your solution. It's a RAID controller, basically, but has a lot more features, right? Then there is the management nodes. We do have 2 management nodes in there. So initially, we wanted to have like a primary, secondary kind of solution where they would take over and do failover if one went down. So in the initial release, we couldn't do that. So one of the management applications is called the HMC, the hardware management control. They shipped on their own appliance, so we had to use it on the secondary node. So, we're now working to virtualize this application, move it to the primary node so that we can implement the automatic failover, right? So if you take a look at all the components of the rack, they all have redundancy. So it's designed to be always up, right? So if one of the switches, for example, fails or there's a problem, so the other one automatically takes over, and so on and so forth. You can see only one V7000, but the V7000 has a feature within it. It's composed of 2 canisters, so it already has built-in redundancy. So everything redundant, that's the key here. And just quickly, these are some of the ways that you can make the solution different, right? So you can have different configurations with maximum compute nodes. So if your applications are more, they need more processing power, or you may have a maximum storage or a mixed hybrid configuration, right? And of course, you can mix and match these, but these are the ones that come pre-configured that you can order. So why Nagios? We evaluated some different others open source monitoring solutions. So you guys probably know most of them here. It's not a very scientific approach, but we look at okay, so what are the search trends on the internet about these solutions, right? So it shows how many people are using them. Roughly, and also we had other research data to look on, but mostly was the reason for the decision was that Nagios already had an established community. It is open source, and it has a path to a commercial solution that the customers can buy, and they have support for it and everything. And interesting enough, there is a good support for Power. There are people that compiled it on Power systems, and they have lots of plugins already for monitoring Power systems. So that's basically why we decided to go, right? So why Nagios alone is not enough now. So So look at that Nagios core, and I want to be very clear with that. We wanted like an open source solution and not a commercial solution to get started with to ship on the product, right? So, so some of the strengths for Nagios is, of course, monitoring. So it does a very good job at it. But on a converged solution, what we wanted is something that gives us a view of all the components that we have, and it will be very easy to like add a component. And in a customer environment, you would be adding a component, and you need to do a lot of configuration on Nagios and the monitoring infrastructure itself to be able to monitor these extra components, right? So we worked on that, and then we came up with an architecture that has our application running alongside Nagios core. So we call it PureMgr. So I'm going to get more details for that. But some of the things that we also do in this PureMgr, besides integrating with Nagios and configuring the SNMP infrastructure and the monitoring infrastructure, so we wanted to tackle, at least initially, some at least some starting of functions for virtualization management, provisioning of the nodes on the converged infrastructure, right? Service and maintenance, like I said, inventory. We wanted to have a view of all the components that are there in the rack, their location, and their serial numbers, and their user IDs, and kind of information about them, right? Configuration management, compliance and updates, this is important as well. So some of these components in the converged infrastructure, they keep getting fixed packs and new versions, so we wanted to, a way to easily maintain the whole infrastructure up to date, right? And also high availability, redundancy, and failover, like I discussed briefly before. So, and now a little bit about the philosophy of this architecture, right? So we wanted to not build something if that was already available in some of the other components in the solution. So we do a lot of reuse. And I'm going to show more about the management stack later. There are several applications running in parallel, and Nagios monitors them, and it makes it gives a good single pane of glass view of all the problems that are in the network. But if you need to do a deep dive, we integrated launching to these other applications, and so that somebody would be able to go in them and do a deep analysis of a problem, right? Okay, so this is the architecture view. So you have the converged solution there, and there is the physical layer, of course, and then there is a firmware that runs on each of these components. So it's what we call hardware management there. I put just a few as example, but there are many more, right? So HMC, for example, is that appliance that I mentioned before that its function is to actually go and monitor all the power nodes in the solution. So it is a product that IBM had for a long time, and it's good at what it does, right? So, but we needed we need other components in the solution as well. So there's a V7K. It has a firmware interface that you can use to do deep dive analysis, etc. So this is what it comes when you buy these components separately, right? So then we want to integrate these into a converged solution. So the next is a stack about performing virtualization management. So that stack is composed of hypervisors that run in the power nodes, and of course the virtual machines that you deploy on top of it, right? So this converged solution is not made for you to run like just 12 operating systems because you have 12 nodes. It's made for you to run like several hundred virtual operating systems on it, right? So we call virtual machines or guests, or it's different terminology depending on the hypervisor technology. And then on top of that, it is the what we call the management stack. So this is what we have running in those two primary and secondary management nodes. So there is one application on the Power family of products on IBM. It's called PowerVC. I'm not going to go into detail on that, but it does a good job of doing management of the virtualization of the virtualization stack, the solution. So it gives you a view of all the resources that you have to share with the virtual machines. It gives a view of the virtual machines themselves and makes it easier to deploy them and to do kind of move those virtual machines around into different nodes and things like that, right? So what I'm going to focus more is in the higher stack, a higher element on the stack there. It's where we have this PureMgr application that we built and Nagios running alongside each other. So the exploded view to the right gives a little bit of detail on how we wanted to build it. So we have the Nagios core. And actually, Nagios core is composed of the daemon and the UI, right? But kind of just for the sake of illustration here, we divided Nagios UI and Nagios core. Then we also have a mirror kind of architecture. We have a daemon that runs alongside the Nagios server. And I'm going to show more later, but once you add new components to your converged infrastructure, we have plugins as well, similar to the Nagios plugins. So you have a plugin to monitor the power systems, for example, and we have a plugin that handles adding power systems to the environment. So it collects all the inventory information, and it automatically configures SNMP for Nagios, and it configures the Nagios configuration as well. But I'm going to go a little bit more detail on that. So I made this chart so you guys don't get very confused on when I show the next chart. So this is what runs in those 10 to 12 power nodes that you have in the converged solution, right? You have a hypervisor in each of these power nodes, and this is the architecture that is used in the what they call PowerVM. It's one of the hypervisors that it's capable of running. For PowerVM to work, it works a little bit different for those who know a little bit more about KVM, for example. KVM has a different architecture, right? So with PowerVM, you have virtual I/O server, VIOS, and it is a redundant configuration as well. So if one goes down, the other takes over automatically. So these VIOS, they're responsible by providing the networking resources and the storage resources that are shared with all the virtual machines. And the terminology that they have for that, for the payloads that the user deploys, it's LPAR, it's a logical partition. So in KVM, you know that as a VM, right? So in the PowerVM world, it's known as LPAR. And it supports AIX, Linux, and IBM for those who know West 400 from later. That's the same thing, basically. It's an evolution from that. So these three kinds of operating systems, they run as virtual machines on the power nodes. And down there, you can see the HMC as a hardware management console. So the HMC is the standard application that works in this PowerVM architecture to do the monitoring. So it talks to the VIOS, so it knows all the resources that are used by each of the LPARs. And it gives a nice user interface view and nice APIs. And we actually use these APIs to do active probes from Nagios to monitor the state of the power nodes, right? Power nodes and the LPARs running on it. Okay, so this is the picture I referred to before. So you may ask here now, so this is a converged infrastructure based on Power. So why are you guys using x86 to run your management stack, right? One of the main reasons was the HMC, that application that I talked about before. It is an appliance, and today it is only supported to run on x86. So because we wanted to virtualize that and have this primary, secondary, and automatic failover function, we decided to go with a management node that is based on x86 architecture. Eventually, at some time, when the components get all ported to running Power, we might do the switch. But for now, these things run on x86. So it also has a hypervisor on the Power on the x86 nodes, and this time we use KVM, right? It's all Red Hat. And then we have 3 virtual machines. One is the PowerVC application I mentioned before. It does the virtualization management. The other is a service partition. We use this to do provisioning, and to do provisioning, we use an open source solution called XCAT. We use that because it has good support for deploying to Power already, right? Besides that, this also runs in a customer environment. So if there is any need to do troubleshooting or redeploy a component in the solution, typically either the customer itself or an IBM technical support person would go to that partition. It's separate from the user environment, so it has no knowledge of the data that is being monitored or any of the applications or any of the L parts that the user deploys, right? So typically we would go there and use that on a running environment to do troubleshooting and fixing. And then there is the main focus, where we have the PureMgr and Nagios running. So the functions that we initially targeted for this first offering was monitoring, of course. Nagios is responsible by that. And then configuration, inventory, and I'm going to talk more about that, but we have a custom user interface as well that integrates all these other applications that are running the solution, like I mentioned before. So from that application, you can launch, you can initially see if there is any problems on Nagios, right? And then you can launch directly to the HMC, to the v7k user interface, to the other firmware and applications that are running in the stack, and to PowerVC as well, of course. This is a screenshot of the integration screen that I was talking about. So we have the categories of the stacks. So we call it converged infrastructure management, but it's more like that integrated management architecture view that I gave before. Then there's virtualization management, PowerVC, and we envision this as expanding in the future, like more open source solutions or other products, like somebody wants to plug the Nagios log server, for example, we'll plug in there, right? And same thing for PowerVC. PowerVC does a good job of managing PowerVM, but you might want to deploy your own OpenStack dashboard in there instead, right? And then the hardware management is the HMC, the v7k, the switch user interfaces. You can link and click and go directly to those. Okay, so this next screenshot is just a view of the inventory information that we have. There are more inventory information besides what we're showing here, but this is mostly what the user is interested on knowing, right? So where exactly are the components on the rack? Well, the user ID used it for management of these components, the IP address and network information, etc. So there's a consolidated view that they can go and refer to if they need to locate something in the solution. One other thing we did, it's tied to the inventory management right now, but so one of the biggest problems a customer has when they buy one of such racks is that it comes with a private networking configured, and they might want to make it accessible to their own internet or to the internet through a gateway or a firewall or something. So they need an easy way to reconfigure all components on the system, right? So that's why we have this function in there. So they can go and configure individually or on a batch to put this endpoint to a different gateway, for example, and then make all the components. They click and it goes one by one and reconfigures to run into the customer network, right? So this is just a view of a compliance updates function that I mentioned before. It shows what every component is running, and there are three main columns there. One is the installed version that they have currently running. The other is what we call base version. So because you have a bunch of things that we throw together, right? So sometimes they don't go well. So for example, you get the latest version of the BIOS firmware. Maybe it doesn't, it requires something else on a different level of a PowerVC, for example. So that's why we have the concept of the stack versions. So this means that all these versions were tested together and they work well together, right? So that's where we want then the customer, we want the customer to migrate to when new stacks are made available, right? And then there's the recommended version. So this is, for example, if there is a problem or a security vulnerability in one of these things, so they get published with new versions of the firmware or fixed specs. And if that gets done, we also test and make it available, and then we notify the customers they're running something that has the potential to have bugs and, or that don't work together very well, right? But not going to be much time on this. So this is where I wanted to get at, how building for this, right? So how we integrate PureMgr and Nagios together. So like I said, we have an architecture that has a daemon running alongside the Nagios server, and we have a user interface that launches to the Nagios user interface as well, and we have mirrored plugins as well. So we have plugins for monitoring the Mellanox switch, the Brocade switch, and we also have plugins on our side to be able to collect the inventory that we need from these components and to do the automated configuration of the, if you start monitoring a Mellanox switch, for example, it will deploy the Nagios, the corresponding Nagios plugin for the Mellanox. It will go and configure. We use a SNMP proxy to do the passive checks, right? So all the components, they have to be configured to send traps to this SNMP proxy that runs in this virtual machine. And then, of course, this trap SNMP proxy has to be configured to go through SNMP TT to translate those traps into something that Nagios understands. So we configure the trap mapping. We don't use a direct mapping between the traps, just like copying out information on the trap. So we actually go and at least the main traps, we try to make it then more legible for the user. So sometimes they come with really cryptical messages, right? So we do some processing on the trap map, and that's another thing that the plugin does. It deploys the mapping that make those traps show up in Nagios to be more legible. And of course, also some of these Nagios plugins that we custom built, they have they go and do SNMP gets. They also do like active checks, right? So and then this goes through the proxy as well. We wanted to do everything through the proxy because sometimes there are requirements for other applications to be able to see those traps as well. So if there is any need, they'll go through just configure a subscriber to the SNMP proxy, right? Oops. Okay, I'm going to go quicker through here because we're getting to the and close to the end of the presentation, but this is just screenshots of some of the active checks, and it's not optimal right now, but we, this one doesn't have it, but what I want to say is we only have, to receive the SNMP traps, we didn't integrate any custom plugin like I forgot the name, but there is a SNMP plugin that you guys can use in Nagios to see a nice view of all the traps, right? So we don't do that. So these are some of the active checks that we do for the power nodes. And you can see, for example, we just check the main things. So for example, if there is a system-led error, that means it can mean different errors that the HMC is monitoring. So if there is anything wrong, the HMC will let me know through this. So it will make the system-led warning or critical information to come here. And then typically, some of these errors, you have to go and launch the HMC to drill down and see what really is going on, or to recover from it, right? Oops, sorry. This shows what I wanted to show before. So for the trap, we just show the traps as a check in Nagios, but one of the things we want to do later is to have like a custom plugin that shows them more nicely, right? And you guys can see some of the active checks that we do here. I'm not going to go into a lot of detail here, but these plugins, they are available in Nagios Exchange, so they can be expanded. If there is any other active check that somebody feels that they should be doing, it can be easily extended there. And this shows the checks that we do for the switches, right? And one other thing that I wanted to say, so one of the components that we monitor, there is also a smart PDU in that rack. We actually monitor SNMP traps and do active checks on that PDU as well. So it's nice to see how much energy it's consuming. It gives you a VA, volt versus ampere information, so you can properly size to capacity. If you need to put more power nodes, you want that information to be able to see how much it's consuming and how much you can put in there, right? So I'm going to go quick through this as well. So what else should we monitor? So besides these active and passive checks that we do on all the components, one other thing we wanted to do is monitor the virtual machines themselves. And then basically, there are many ways to do that, and I'm going to refer you guys back to a presentation that was here in the Nagios World Conference in 2014. It's a presentation about monitoring OpenStack, right? So it's similar here. So PowerVC, it also implements some of the services from OpenStack, but one of the things that PowerVC doesn't have right now is a ceilometer service. So we didn't have that option to start with. So, and then the other alternative that was discussed before was use a provisioning tool to deploy NRPE agents or any other types of agents to those virtual machines, like a Puppet on Ansible. We thought it was overkill just to do that, just for using those solutions. So what we ended up doing is we built our own deployment infrastructure using Python, right? So it's simple, just do an SSH to the application. We have prepackaged agents that has plugins that we want to be there to monitor stuff on the VMs, and it goes and install that. And this is just a graphical depiction of how it works, right? So we also have PureMgr plugins for each of the VM types. They go and they are responsible for deploying the NRPE agents, and then the NRPE agents feed back the data to Nagios, right? And this is just a screenshot of that function. So you probably don't want to monitor all your VMs, like you can have hundreds of VMs running on the converged infrastructure. You want to monitor mostly the ones that are critical for production, running your DB2 server or your WebSphere server or something else that is critical for production, right? Our solution doesn't scale well yet. It's one of the things we want to work next. So if one of these virtual machines is moved to another power node, you have to come back here and redeploy the agent, or not redeploy, just synchronize it with the NRP agent that was moved, right? But typically, you go to this screenshot, you have to manually go there and make sure that all your agents are running as they should, and they have the versions of the agents that you want running there, right? So scalability, we're starting to work a little bit more on that. So right now, the only solution is to like have your tactical plugin choice, so MNTOS or Nagios Fusion, for example. But it would be something that is running outside of the racks. So inside of the racks, each of the racks have an instance of Nagios server and an instance of the PureMgr, right? So in the future, what we want to do is expand that PureMgr and that Nagios instance to monitor components from other racks as well. So we're going to give a guided wizard to the customer. Okay, so you have to wire this port to this port on the other rack, and like guide them through exactly what they have to do, and then automatically configure the networking to access multiple racks, and also then start monitoring as it was a single infrastructure through different racks as well, right? Just some benefits of the integration, like this mirrored architecture. It gives a very easy way to, so if you need to support a new component, you can just create a new plugin for PureMgr, a new plugin for Nagios, and you can expand it, right? There's the launch integration, automated agent deployment capabilities. So these things, I think we added to the solution, and I think both Nagios and the converged infrastructure solution, they benefit about, right? So possible ideas for the future. I'll let you guys read more about it. So one of the things we want to do is explore integrating Ganglia on the equation too. Ganglia has some strengths. Nagios has different strengths, so we want to see what it makes more sense to do performance management. We want to support KVM running on the Power environment as well. We want to make the solution cheaper. So there's a industry council called Open Power that basically there are other vendors that produce cheaper power nodes. So we want to be able to integrate those as well, and so on and so forth. So there's ideas, and if you guys have any ideas where you think we could benefit of having an integrated solution like this running in the management stack, you can come to us and we'll consider it. And some references, links to the plugins. I think there is one more. I didn't update the presentation here, and to find out more about PurePower as well. And I apologize, I kind of run a little later, so I'm going to open for questions now.
Any questions?
Thanks. Just quick on the, how do you go about monitoring the SANs, or what kind of information can you get from your SAN
the
storage?
SANs, yeah, I actually showed some of the information in one of the screenshots, but I had to go much quicker, right? So. Yeah, we monitor the Ferber channel port status. What else do we monitor, Billy? Yeah, and of course all the SNMP traps as well. They're sending SNMP traps back to Nagios, right?
One of the hopes is that we have lab-based services that will help customers get modern one of the hopes is that we have lab-based services that will help customers develop the monitoring they need, and then that would get fed back into our future iterations of our product.
Yeah, and one other thing is, like I said, these plugins are open. If you need to expand and add new checks in there, you can do that as well. One thing I didn't mention before, but is Nagios and PureMgr, they are running in a way that you can have recovery. So all the data and the plugins for Nagios, they are kept in a separate safe storage. So if you want to put different plugins, you can. And then when we upgrade a new release of the PureMgr and Nagios nodes, it just takes over the existing plugins that you had before, right? So it is designed to be expandable. It's just an introduction, but you can add your own checks to it as well.
So how does the upgrade process works? This is the management interface now, which is IBM. It's x86 based on Rails 7.1. And say, for example, you have Nagios 4.408. And if I want to update to Nagios 4.1, what is the process?
So yeah, the customer can do it by themselves. But we are going to also be releasing fixes and new releases once a quarter. So now with, I don't know if there will be a Nagios Core 5 or if it's only XI, for example, but once there's new versions of Nagios, we're going to release that as well.
And what about the add-on modules like life status and all that? Can I install them?
I'm sorry?
Life status module? Can I add the life status broker within the Nagios setup that you have? Do you support that?
You can. There are some manual steps that need to be done, but certainly it's possible.
Because it's a Rails 7.1, right? It's a Rails 7.1 where the Nagios runs on, right? It's not a customized Red Hat Linux you're running on it, right? It's just a normal Linux, base Linux
normal.
setup.
Yeah, it's normal.
I can just add the libraries, but do you support? IBM supports it?
You can actually go and do an update on Red Hat, and it will download all your packages. But like I said, once a quarter, we'll try to keep up with what's published out there. Right.
And then when you say elasticity, when I spin up new LPAR, add a new server, how does Nagios knows about? Do you have any kind of a job running and constantly?
Right, that's the reason why we have the PureMgr service running alongside. So there's a new LPAR. We're going to detect that from PowerVC and give you the option to deploy an RPE agent on that.
Okay,
right.
And what about adding that to the monitoring? It's the same type?
It's the same. The user just clicks a button, it deploys an RPE agent and configures everything for you. And
what about the SNMP proxy that you talked about? Is that proprietary? Is it something available in the community that we can use?
Yeah, the plugins we already deployed to Nagios Exchange. We already submitted to Nagios Exchange, right? The PureMgr itself is not yet. We didn't feel it's on a place yet to actually release that in open source yet. There are more enhancements that we want to do on it. And like I said, there's a big problem with scalability right now, right? So we want to fix that first and then also think about releasing that in open source as well.
Okay, thank you.
Any other questions?
How does your high availability solution work exactly?
So in the current version right now, it's not automatic. So you have a primary node and a secondary node that is in passive mode, right? So if something happens in one of the components, then you have to manually go and switch to the secondary, and then it takes over. Like I said, the data of all the applications that are running is a separate storage. So it should be able to take over seamlessly, right? In the near future, what we want to do is have an automatic failover when something is detected that, for example, one of the components went down or there's a hardware failure on the hardware running the primary node. We want to detect that and do automatic failover to the secondary, but that we're not there yet.
Anybody else?
Sorry, if we need to talk after, we can. I work with some clients with small installations, just basically one power box running PowerVM and AIX VMs inside of that without an HMC. So do you have any recommendations for monitoring like the PowerVM server, or the VIOS, or running any NRP agents directly on that? And then are there any recommended NRP agents for like AIX nodes?
Good question. So usually what IBM works with and recommends to monitor power nodes is the HMC. But like I said, yours is a small deployment, right? One thing that you can do, and it's one thing that we're thinking on doing as well, is get rid of the HMC and start monitoring to IPMI and going to the OS itself. We're mostly thinking on doing that when we move to Power KVM. So right now you have the hypervisor being PowerVM, right? When you go to Power KVM, HMC is not going to be able to manage that anymore, right? So then what we're thinking of doing is implementing, going straight to the IPMI and getting the data there to monitor the physical attributes of the power node, and also having an RP agent running on the Power KVM operating system and hypervisor, right? I think this will be the best bet right now, going directly to the firmware and doing the probes there, but that's not how our plugin works right now. Our plugin goes through the HMC, right?
Any more? All right, ladies and gentlemen, once again, please, Marcelo Perazolo.